All right, so I'm still looking through this paper on generalized linear models, and I'll include the link for the full playlist for this video series, basically just going through this paper in detail. I'm doing a side video here due to a question someone had left, basically asking me to go into more detail about this exponential family distribution and to maybe show an example of what alpha this alpha function is, what this g function, h function, and beta function all are. All right, and I just want to point out, first off, so this is an exponential family distribution, which is different than the exponential distribution, right? So an exponential distribution is a member of the family, but exponential family type distributions includes more than just the exponential distribution. So for example, the normal distribution comes from an exponential family. The gamma distribution comes from an exponential family. The exponential distribution comes from the exponential family. All right, so I'm going to show an example. I'll show that the normal distribution can be written to look like this. And in my previous video, I kind of just mentioned that was a fun exercise for you to do on your own. But let's go ahead, and in this video, I'll go ahead and show an example. So moving now to my Blackboard. Okay, so this is basically the format I want to make the normal distribution look like. And we all know the normal distribution, so let's just do a simple one variable normal distribution would be f of x equals 1 over the square root of 2 pi sigma squared times e to the power of -1 or x minus mu squared divided by 2 sigma squared. Okay, and so this is what the normal distribution looks like. So how do I make this look like this? That's basically my challenge right now. All right, so first thing, we can see that here we have the random variable z, and here I have the random variable x. So the first thing that I might do is go ahead and replace that x with a z. All right, so I'm not doing anything. I'm just trying to make one look like the other. Okay, so exactly the same here. Negative z minus mu. So at this point, I don't know. I don't know if mu is going to be phi, or if theta is going to be, or if mu is going to be theta, mu is going to be phi, or if sigma is going to be phi, or sigma is going to be theta. I have to kind of figure that out by making this look like this. So one of the first things I need to notice is that in this format here, everything is in our exponential. So what should I do? I need to bring this piece here into the exponential. So how do I do that? All right, I'm going to use basically a little clever math trick wherein the exponential of a log, right? These will cancel each other. So I haven't actually done anything that I'm not allowed to do, right? This is exactly the same as this, right? So this times all this jazz in the back. Okay. So remember, this is 1 over the square root. That's basically -1/2 power, right? So using our properties of logs, we can basically ski slope that power down, and I have -1/2 times the log of 2 pi sigma squared. Just kind of making that look a little neater. Okay. Now, if I have this exponential times another exponential, I can bring those two exponentials together with a plus sign, right? So using properties of my exponentials, right? And I still have this minus negative, or this negative z minus mu squared divided by 2 sigma squared. All right, so now you see I have everything inside one exponential, so you can see I'm getting closer to having something like this right at the top, where I have just one exponential. Okay, so let's keep moving. I want to go ahead and expand this term here. Okay. So let me scroll down. So I have exponential of, I'll leave this alone for right now, this log. Okay, I'll leave that alone. And I'm going to expand this, so I'll end up having, I'll make this plus minus into a minus. I'll have z squared plus 2 mu z, or actually let me write that z mu. Okay. And that would be a minus sign because of this minus here, not plus. Let me change that. So minus 2 z mu, okay, and then plus mu squared. All that over 2 sigma squared, okay? All right, so now let me go ahead and distribute that negative sign. All right, and then also I'm gonna just rearrange this and put all of this stuff in the back because, well, eventually, going up top here, I want to have all my, I want to make it look like this. I think that if I put this in the back, it'll just look a little neater. So just basically rearranging a sum, or rearranging this difference, right? So yeah, I'll go ahead and write it first. So I have negative 1/2. So I'm just rearranging, putting this in the back. Okay, and then for this part up front, I'm going to go ahead and distribute that negative and also write this 2 sigma squared over each piece. Okay, so I'll end up with negative z squared over 2 sigma squared plus 2z mu over 2 sigma squared minus mu squared over 2 sigma squared. Okay, and all that is minus this. Okay, so I see I have a little bit of cancellation here. This will cancel here. All right, do I have anything else that cancels? Not really. Okay, so I have equals. Okay. At this point, before I write, I'm gonna go back up. I know I want z times theta, right? So and that's positive, z times theta. So I'm gonna go ahead and put this first, this term right here first, because it has z and it's not squared. Okay, so z times theta. It's looking like theta might be mu, right? Since I have z mu. Okay, divided by sigma squared. And then minus, let me go back up there. So I have something that only involves theta and then something that only involves z. Okay, so I'll go ahead and put this term second. And then my term that only involves z in the back. This could potentially be h, the function h of z. Okay, make sure looks good. Okay, make sure I didn't mess up my signs. So this one's positive, this one's negative, and that one's negative. Okay, and then minus 1/2 log. Okay, we're almost there. So now at this point, since I want it to just be z times theta, again, theta is looking like it's going to be mu, right? Z times theta is what I want. So I need to basically pull out whatever's not z times theta, which would be I need to pull out this sigma squared. Or factor it out. Okay, so I get z times mu minus mu squared over 2 minus z squared over 2. Close those parentheses, okay? Then minus 1 over 2 times log. Okay. All right, so at this point, I want to try to figure out, identify what is phi and what is theta. So theta is mu. We can see that because I have z times mu. So I'm going to go and write that. Theta is mu, and phi then will be sigma squared. So let me plug that in. So I'll have, actually, let me not make that sigma squared, but just sigma. That makes more sense. Okay. So I'll have phi squared, z times theta, minus theta squared over 2, minus z over 2, and then log of 2 pi phi squared. Okay. So now I just need to identify what all my functions are. Okay. So alpha of phi. Actually, to make this a little easier, I am going to go ahead and rewrite. So remember, I'm trying to make it look like, let me rewrite it here. My function, the exponential family distribution functions, they look like this. Okay, I have alpha of phi, z theta, minus g of theta. I always get my signs mixed up, so be careful with your signs. Plus h of z. Okay. Plus beta of phi and z. Alright, so I just have to identify each piece now. So alpha of phi, a function of phi, that's going to be this piece right here. Okay. Alpha of phi is 1 over phi squared. Okay. Next, I have z times theta. That was an important thing that I needed that to be exactly looking like that. All right, so that's good to go. All right. Next, I have g of theta. So a piece that is just of theta. Okay. So g, a function of theta, is going to be theta squared over 2. All right. Then I have h of z. That'll be this piece back here. Okay. Including that negative sign because this is a plus right here. So h of z will equal negative z squared over 2. All right. And then lastly, this function of phi and z. Now it doesn't include z, but that's okay. It doesn't have to include z, but it can. All right. So this last piece back here is, or beta, which is a function of phi and z, right? And it doesn't include z, and that's okay. Will be this negative 1/2 log of 2 pi phi squared. Okay. All right. So then once you're here, you know what each of these, you know how this exponential family distribution looks. You know, you're able to use these functions alpha, g, h, beta to find other things, you know, really conveniently, like the variance, expected value, other things like that. So it is helpful to know how your distribution function can be written like this. But it's just a matter of basically algebraic manipulation to make it happen.